All right, so I think this is recording. The the degree of this is 3, which is an odd number. The leading coefficient is positive 1. The leading coefficient theorem tells us the end behavior then, since the leading coefficient is positive and the degree is odd, that as you move to the left, you're going down on the graph, or as you move to the right, you're going up. When it's in standard form, the y-intercept is the constant term. So this would have coordinates 0, -20. There is a theorem that will help us generate and find possible rational zeros. It won't help us with irrational numbers, but it'll help us with rational numbers. And it uses the factors of 20 and the constant term and the factors of the leading coefficient to generate this list. So now the game begins in trying to search through this list, and unfortunately we could end up searching through the entire list and not find any zeros. There's no guarantee that any of these are zeros, but if there is a rational zero, then it's going to be in this list. We can sometimes, when it's 1 or -1, I don't do synthetic division. I just look at it and add up the values to see if I get a 0 or not. So if I plug in 1, and sometimes this list will contain fractions, and I may have to eventually try some of these larger numbers, but since arithmetic is so easy when you have ones and -1s, I almost always try those first in hopes that that's one of the zeros. So if we plug in 1, we get 1 plus 9 plus 11 minus 20, and that's not equal to 0. What about -1? Oh no, we don't get 9. What? Gosh, I'm stupid. I must have added up the 1 plus 8. I don't know what I did. Take that back. 1 plus 8 plus 11, and hey, that is 0. So we got lucky that we found it right off the bat. You won't always get so lucky. It just happened to be that way. So now I want to do synthetic division, because this doesn't help me factor it. It just helps tell me what a factor is, x minus 1, but it doesn't help me to actually factor it. The synthetic division actually helps me factor it. So what that means, that this x cubed, this third degree polynomial, factors to x minus 1 and x squared plus 9x plus 20. So we set this equal to 0 and solve this equation. Now this quadratic, maybe it factors, maybe we have to use the quadratic formula. If you don't like factoring, if it doesn't work, it's just that the quadratic formula usually takes a lot longer time and more effort than factoring. But technically, I guess if you were fast enough at it, you could do it. So this factors to x plus 4 times x plus 5. All right, so we have factored that completely, and now we can, a table is just an organized way to tell people what the zeros of this function are, and also the multiplicity, and to describe how it intersects the x-axis. Zeros are just another word for x-intercepts, and sometimes you'll see it called roots in older textbooks. So 1, -4, and -5 are all zeros. They all have a multiplicity of 1. Since 1 is an odd number, it crosses over the x-axis. None of these are a touch and turn situation. All right, so that's what it wanted. So I hope that helps, and I'll talk to you later. Bye.